Thank you. Thanks a lot, firstly, for the opportunity to speak. And, when it comes to manufacturing, I'm really, intrigued by it in the sense, I feel that, there is a lot of innovation and there is a lot of technology consumption that happens in the manufacturing world. And I was just looking at Mr. Marathe's presentation. He said 1760. So from 1760, I think the manufacturing world has done a lot of good for humanity. And he also called out connected process, connected assets, connected people, and change in mindset. And I think that's the area where probably Red Hat can play a very crucial role. Now, if you look at the shop floor to top floor, or vice versa, also top floor to shop floor, there are a lot of assets within the organization, and each has its different kind of requirements from a technology point of view. The platform that needs to support these assets kind of very as and pardon me, I'm calling the MES systems and also the ERP systems as asset. I really mean that. I mean, like, I know that in manufacturing world, asset is something that is on the field, but just for excuse me for that, but if you look at the entire spread of technology which is there in manufacturing industry, it's massive. And if you look at the data centers, you have the ERP systems out over there, the information technology systems out over there. And as you progressively move towards the shop floor, what you see is, huge amount of sensors and equipments that are kind of, actually working on the hard process, which is essentially then kind of, leads to completion of the product. And our observation has been that, the requirement changes, like I mean, like, if you look at number of equipments that are needed probably in the data center, probably 1, 2, 3, 4, or depending on the organization, sometimes maximum in terms of 50s. But as you move towards the operational technology, the number of equipment that one has to deal with is in hundreds of thousands. And the requirement from a footprint point of view, while in the data center would be like massive, huge system, but on the devices side, on the actuator side, on the sensor side, maybe the footprint has to be simple, small, but yet has to be scalable, because there are so many equipments that you're dealing with. I just wanted to do next in context drill down onto how would this pan out in terms of systems within the organization. Just a high level block diagram of the well-known ISA 95. I just picked up that, and just kind of if you look at it, what you see today is like the boundaries which are there between the top floor, where the executives sit or the management sits, or management decisions happen, or the ERP systems sit, to the field level, that those boundaries are slowly disappearing. I learned a lot from some of the very interesting videos that come on YouTube, especially the mega factory ones. I came across one such presentation, and that one such presentation was of a car manufacturer. They had 400 robots who are manufacturing 400 cars daily. And I was just looking at the mathematics from a productivity point of view. One is 400 cars doing 400 robots, or robots preparing 400 cars. The other was the total employee in that particular factory is somewhere around 4,000, and they manufacture somewhere around 80,000 equipments. And that is really very interesting. So many things happen, and in that setup, they have an option where a customer could say that hey, I want to customize the car at the shop floor itself. Okay, I'm just taking a car example over here. I think it's applicable to many other industries as well today. But imagine a customer who says that, hey, I want, ABC in my car, okay, or I'm more of a rally guy, I want this changes, and his request flows through that ERP system to various other systems which are there, which are monitoring those actuators, and eventually, he says, okay, car rally, it goes in, dark, you say mountains and jungles, and I want it to be yellow color. That request, essentially goes into that actuator, and then the paint that gets selected automatically is yellow color for that particular car. So, really very fascinating. So the boundaries really are kind of, disappearing. But then, is, how is kind of, or what is the avenue for, for us in these technologies to kind of, make it optimal? Can we kind of, have that similar kind of, setup out over here in our industries as well? So if you look at it, the blue block boxes over here, or if you're looking, the highlighted boxes, I would say, these are the systems which are there, which are needed either also in the top floor, as well as it is needed in the shop floor. The compute platform, the platform for applications to be developed is needed in both the places. At the same time, we've been hearing a lot about data and analyzing data. You need data analytics in the top floor, as well as you need data analytics in the shop floor as well, where the actual, data rise, so that, some autonomous decisions could be taken. And especially, the intent of this entire, orchestration is basically to, reduce probably machine failures, basically to improve the quality of the product, improve the productivity of the entire organization, improve, the customer experience, wherein, if there is a customer facing organization, I mean, like all organization customer facing, but, some are B2B and some are B2C. In that, how could you kind of, enhance the customer's experience? So, if we were to kind of, look at, hey, how are various disruptors doing it in the market, and can we kind of, imply that to manufacturing also, and try to see that in manufacturing also we could achieve those efficiencies. So in the disruptors world, what is happening is, in the disruptors world, they are leveraging open source like crazy. And the applications are like, microservices based applications. So just to take an example, what are the disruptors that we know very commonly are like, Netflix, that disrupted, the way the videos are distributed. Ola and Uber, the way kind of, transportation happens over there. Their architectures are very nimble. Their application development is very nimble. They are not, legacy technology heavy. They are mostly using open source technologies, and they have a complete microservices based architecture. And I'll just throw a simple example. Today, if you want to kind of, recharge your account, you could do a Bhim Pay recharge, and there will be a QR code that will come on your account display. You can do that recharge from there, or you want to pay it online, or you want to do some other ways to kind of, make that payment through some bill desk or something of those sorts. Those options are available. Now, imagine, one channel breaks down, doesn't, still you have other channels which are available, and they eventually meet the same end goal of, recharging your account, be whatever services that you're using. So the point is, they all leverage open source technology today, for simple reasons. One is, it is simple. Second is, it is scalable. Third, today, open source, you may not know, but is more complete than the legacy system. And then, the hybrid cloud option that is available, and the open source culture. Now, in this, what you see is, various technologies. What, in that one particular example where, the 400 cars were being manufactured by the 400 robots, there was one particular requirement over there, which I felt was, actually, difficult for a human to accomplish in a day's time, wherein, 5,000 points are to be welded, some 5,300 points are to be welded onto that body, so that, that complete, the top and bottom and top part of the doors and hinges and everything kind of gets connected well in the core body of the car. So I don't know where you guys lost me, but just the point that I wanted to make was in the open source world, there's a lot that's happening, and most of the disruptors are kind of leveraging it. It is very, very important for the manufacturing world also to leverage this technology. And there is one option which is there, which basically kind of could be one building block that. Give me just a moment. I just need to. Sorry, somehow the screen is not okay. The videos is coming in between. Anyways, I'll continue with this. So, the one building block that can basically help, infrastructure in manufacturing companies also, accelerate, especially on the industry 4.0. That one building block is OpenShift. And how it functions is, firstly, this particular building block is multi-cloud, in the sense you would be able to, whatever code that you develop on this particular building block, you would be able to deploy it on a physical infrastructure, on a virtual infrastructure, on a private cloud, on a public cloud, and most importantly, from a manufacturing point of view, on an edge infrastructure. What does it have? It has all the clustering service, which allows it to kind of combine the deployments and make it highly scalable. I'll not be technical out over here, but you'd be able to manage your workload across multiple clouds very easily with this particular platform. It has all the middleware technologies that are needed for you to do the process automation part, integration, API management. See, again, it is very important that the organization also connects well to the ecosystem. So today, on the assembly line where there are feeders, the feeders are coming from, the parts in the feeders are coming from various vendors. How about leveraging technology to make the communication with various vendors, very, very easy. So, all those technologies that are needed are part of it. From analytics point of view, the technology that is needed is part of it. And it's a platform that you could mold to meet any of your challenge that you want to get it solved by means of technology. And we talked about security. From a security point of view, again, very, very important. How do I do separation of duties? How do I do strong internal access control, so that I have a lot of confidence in kind of pushing this data onto this platform. Just imagine, some of the workload of yours is, say, on AWS, some of the work is on Microsoft. I can tell you that our technology is available on Microsoft as well as AWS as a joint service, and hence you and on that you want to build your security roles as per your requirement. That could be built onto this setup very quickly. This is another way of looking at this technology. It's a complete platform available for app modernization and the requirement across the organization when it comes to having a requirement in the shop floor or the requirement in the top floor. Secondly, it could be kind of because it has everything and it has a huge ecosystem. So like MS SQL, Postgre, everyone is kind of certified onto this particular platform. So additional technologies that you need to get to build your complete solution is part of the platform. So here is just an example of Open Data Hub, how in a data hub your requirement is basically acquisition of the data, storing of the data, processing of the data. That entire stuff can be built on this particular platform. Quickly, we all know on the core data center side, things there. On the regional data side, you already have data center side. You would already have assets. But on the edge, is the place, where, we are doing this additional last mile, compute and platform availability, so that you could build apps which are kind of, nimble and, very agile to meet the requirements of your manufacturing, or, the asset optimization. So that's on the complete portfolio. Very quickly, just 2-3 slides on the open source part. Again, this is very, very important because, we talked about the culture. I think Mr. Marathe called it out really very well. He said, change in mindset, very, very important. And I think this is what something we can pick up in the manufacturing industry, can pick up from the open source world and the disruptors in the market. See what's happening in open source world. The most important thing is collaboration. You would always find, people are solving shared problems. They are working together to create standardization, and there is transparency. So no one owns the code. The code is actually, available, and you can't be arm twisted that, hey, you don't pay me the SNS, I'm going to kind of disconnect everything. That's not the world over here. And in fact, if you were to compare it with the legacy systems, the participation is massive, and it's a myth that it is only volunteers who work over there. There are companies that come together to work and then and solve a problem. So just to give an example, for manufacturing, the open manufacturing platform was started by BMW and Bosch. Red Hat has joined it, and we're working on it. And what is done is, what Red Hat's role over here is to kind of, then later on curate and make the software enterprise grade and consumable for enterprise. This is just some of the projects that we have been working, which has been extensively used by industry. And these are, I mean, like, the way we function is, whatever feature functionality we release it in the community. So whatever software that we are kind of making it available to you is also available via community. So that's the best part about Red Hat. And here's one example that I wanted to share. See, like, just we take an example of IoT. From IoT point of view, you need to have strategic members. Who would be the person who would be engaging with the sensors, where is that IP? It is with Bosch, probably Eurotech, so all these guys, and then BMW, and then Red Hat, and then various other partners who are kind of strategic members of this particular initiative. And then there are partners. See, ecosystem also need to kind of adopt to it. Like, if finally that IoT data is going, suppose, into, just for a discussion, into a Cloudera system, then you need to have partner, that integration between the IoT solution that is being created by this community and the partner. So there's lots that happens in terms of collaboration. Just 2 examples. This is one example where POSCO implemented the OpenShift container as a service and Ansible automation to connect their 50 steel plants and have basically integration between them across the organization, across 150 all business lines. Similarly, Ford also adopted the same way, and the advantages that they had was improved productivity, enhanced security. Security was one thing that we were discussing. Then significant reduction in hardware cost. So these are some of the things so that we kind of do. And I just wanted to kind of make one final statement that from Red Hat's point of view, when we engage with the industry, we try to see that we keep the things simple, so that it is adoptable, scalable, so that it meets the requirement as things scale out, and keep it complete in the sense that hey, entire open the ecosystem is also concerned, is kind of considered, and the solution becomes palatable. The again, open in the sense standards are all open, so that there could be more and more collaboration, and obviously, and most importantly, hybrid and open culture. So hybrid cloud in the sense you be able to run your workload wherever you want to, be it on edge, be it on in the data center, or be it with the hyperscalers, or be it with some of the CCSPs that work with us in local regions. And finally, from a culture point of view, there is a lot that we do to bring in, there are a lot of trainings and a lot of workshops that we do to bring, or innovation labs that we do to bring in that culture of innovation, and collectively run along with you to kind of solve a business problem that would be there. So that's all, Nikita, from my side. Thank you.